Okay. Uh, why does it think I'm hosting still? We are clearly streaming. Okay. Uh, try refreshing the page. What is this, 55?
You hear me?
Yeah, I hear you just fine. Do you hear yourself? Can you hear me at all?
Oh, yeah, there's a lot of lag.
Okay, but how's the volume?
Your, let me see. My voice, yeah, my voice is a bit lower than yours, but
All right, let me turn it up. Try that.
testing volume.
I am talking as well.
A bit better. I have like a 5, 6, 7 seconds lag.
Okay. Try that. I just jacked you all the way up.
Okay, testing the volume. Yeah,
That's
that's
better?
much better.
All right, perfect. We'll just leave it like that. Is
Yeah,
interviewing. Your last name is Rodriguez. Okay, I got that right. Rodriguez.
yeah,
Okay, you can mute the other one and go back to the Hangout so you can hear me in real time now.
yeah. Okay.
All right. Is that better? Wait, no, here. Sorry, I had to
Yeah.
unmute myself too.
Okay.
Yeah. All right, is that better?
Yeah, a lot better.
Okay, perfect. Let me update this. All right, we have 3 viewers already. Hooray! Now let's get your video in
Hey.
here. Let's add in the video. Please enter the name of the scene. I don't think so. Let's add in some video capture. Display capture? Game capture. I guess. I'm not entirely sure how to do this. Display capture. We're going to go with display capture, and I'm going to make you the full screen. Let's go F11. There we go. And let's go display capture. Add in display capture. Okay. Screen 2, I guess. That's not the one I wanted. There it is. Okay.
Okay, yep.
Let's get you shrunk down here. And then let's put you behind. Oh no, that's too far. There we go. Now let's pull you up. Okay, let's get you shrunk down a little bit more. There we go. All right, man.
Okay.
Okay, can you see yourself?
Yep.
Hey, all right. Now if I look over here, it looks like I'm looking at you. I guess I can see you because you're going to be on the screen anyway. All right, perfect. All right, so hello everybody. Happy Friday and welcome to the stream. Today is June 28th, 2019. It's about 12:15, so I'm about 16 minutes late. It happens like that sometimes. You might notice that there is somebody else hanging out with me today. This is Juan Rodriguez. He is a developer here at Stack Overflow, and he has been working with me pretty intently. Not intently, I guess. In what's the right word here?
Intensely? No.
A lot lately. And so I decided, hey, why don't you come on the stream and hang out for a little bit, and we'll just chat and see if we can have a little bit of fun today. First off, before we get started, I would like to thank everybody who followed me while I was off stream for this last week. That is G Soster and Body Atomic. Thank you so much for the follows. I really, really appreciate that. And let's go ahead and get started. So first things first, Juan, welcome. Um, how are you doing today?
Hey, great. Thanks for having me, Nick.
All right, great. Well, I mean, how do you feel?
Well, I'm doing great. Let me just make a quick intro of myself. I'm Juan. I'm a developer in the talent team in Stack Overflow, and I work remotely from Uruguay, South America.
That's right. What time is it there?
It's 1 hour ahead of EST, so it's 11:17.
Okay,
Sorry,
11:20.
1:17. Yeah,
1:17. Okay.
yeah,
So, yeah, it's an hour later than here. I also
yeah.
noticed that you are wearing a thick shirt. It must be like fall there or spring there.
No, it's winter. It's
Oh,
like
it's like
really,
full on winter.
yeah, yeah, full
Okay.
winter. Yeah, it's crazy. It's getting really cold.
That's one of the things about like working with people remotely that like always gets me. Anytime I talk to somebody in South America, I'm always just like, it's so weird.
Yeah.
I mean, it's also like I don't know. I've just never been south of the equator, so never had the experience of it being June and cold at the same time.
Yeah, you should
Um,
definitely try it.
all right. So I have got some questions for you. First off, we have been working together for gosh, what, almost 2 weeks now on a project. What have we been working on?
Okay, so basically, we like you work on the data team, and you're trying to experiment with a new targeting algorithm for our job ads that are displayed in Stack Overflow to make the job ads more relevant for the users. And we're trying to experiment with that. And one of the issues that we are facing right now is that the new algorithm is a bit slower than the new one,
A bit.
quite a bit. And in order to make a fair comparison, because we know that latency like has a negative impact on CTR.
Right.
So in order to make a fair comparison between the current algorithm and the new algorithm, we need to make them at the same to get them at the same level of latency.
Yeah.
So we are trying to speed things up on the new one.
Right. 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 Okay. So that's
Well,
mostly
yeah.
what
To
we
be
try
to be
first.
to be honest, first we tried to make the current one, which is the fast version, slower, and we were told, no, folks, don't do that. Don't
Yeah.
make things slower. Try to make the slow thing faster. So yeah,
Right. Right. What? Why? Yeah, that's kind of frustrating too, right? Like when you're working on something and you're like, "Hey, we've got this idea," and you put a lot of effort into it, and then all of a sudden they're just like, "Oh, we can't do that," you know? And it's like, where's the line where you draw like, I should just be able to make the decision that we're going to try this and
yeah.
that's it
Well,
versus not.
well, maybe we should give some context about why we thought making something that's running fast, make it slower was a good idea.
Oh, that's fair.
And the reason is that we're trying to experiment with this, so maybe it doesn't work. Maybe like people click less on the ads, and we're not going to graduate this experiment. So like it was already optimized during a lot of time by the data team, and like putting more effort into it without knowing if we were going to actually use it, like was kind of a hard call to make. So it made sense at that point to make the current one slower for just a couple of weeks to see if this worked. And if this worked, we could then invest time in making it faster.
Right, right. And we had yeah, so I guess a little bit of more context here. So when we were designing this, we had completely decided that like this needs to run single threaded, like that's just the way it is because going to our architecture team and asking them to run something multi-threaded on the web tier in every single instance that we have done it previously to my knowledge has caused like catastrophic failure. And so we just sort of skipped the idea of doing that altogether and then decided, if these requests just take a little bit longer, then that'll be fine. We also spent a lot of developer time trying to like optimize it. This is me working on it. This is Kevin working on it. Kevin's my boss. And then like we spent a solid 2 weeks doing nothing but trying to optimize this. And then the third week, we knew we still had like a ways to go. But we switched gears to trying to like get it into a production setting so that we could actually test what it was going to be like in a production setting. And in the course of doing that, we identified that our fastest solution was sort of making some assumptions that didn't really hold for prod, and that ended up slowing it down quite a bit. So we swapped out to our second fastest solution, which was a little more resilient to the way that prod works. And we'll get in, we'll explain that, a little bit later. But for now, it should just suffice to say that like the idea of running something in parallel was just like not an option, like as we were designing this thing. But yeah. So anyway, go ahead and continue.
Yeah. So I mean, the idea of the idea of making it slower. Maybe we can give some insights in what were we trying to do. Was to actually to make the first one slower, but we didn't want to inject a fixed amount of latency. So we actually worked quite a lot in order to make the distribution of the latency of the baseline and on the experiment to match. And they have different distributions. So, and the distributions actually like the numbers of latency, the latency numbers, like they change a lot during the time of the day and the day of the week. So we also want an algorithm that automatically adjusts for that. So the main idea for that was taking samples of the latency on the
Do you happen to have the tool available right now that you use to like run the samples here? Like, can you show us the graphs of visual representation of what we're trying to achieve?
Yeah, absolutely. Let me
make sure you clear everything off your screen except for like R.
Yeah.
And I'll blow you up here so you're nice and big.
So the main objective was this. We expected to have a latency on the baseline. So let's say
which one
that
of these is the baseline?
The baseline is the red one. So let's say that the red one was the baseline latency, and we had a green one, which was the experiment latency. And the idea was to inject latency to the users so that the red distribution of latency transformed into the green one.
Okay.
So the way that we did this was to actually try the percentiles to match. So what we did was to split the red latency in 100 percentile buckets, and the same thing with the green one, and then try to like calculate the distance between the first percentile of the red one and the first percentile of the green one. And whenever we received a request for the baseline, what we would do first was, hey, let me see in which percentile of the baseline distribution this falls. Let's say that it fell in the 20th one. So let's see what's the distance, and let's transform it so that it falls into the 20th percentile of the green one.
And how do you do that transformation?
The transformation, well, actually what we did...
not the math, but like how do you make it so that... How are you measuring that a request is in the 20th percentile? And how are you transforming it to be in the 20th percentile to match what we expect the other distribution to be?
Well, the measurement was... This is done by a collector. Like, so when... we coded a collector which actually measures all the requests, how long it takes.
Okay, it's the time. I got it. Okay.
Yeah, this is using a stopwatch, and after the algorithm finishes, we check. Okay, so this is the latency for this request. Let's do the math to check on which percentile of the baseline distribution it falls.
Okay.
So it falls into the 20th one. We're going to check what's the distance between the 20th percentile in the baseline and in the experiment, and just add that distance. That's the latency that we need to add. And yeah, that's here what the blue chart shows, the blue histogram shows, is actually the red one transformed already into the green one. And as you can see, it's fairly similar. It's pretty
Right.
similar.
Yeah, I definitely see
Uh,
like yeah, there's a little bit of differences on like individual buckets, especially up there on the high end, but like overall it seems to be pretty good.
yeah. Yeah, I mean, the main idea is that we didn't need this to be super accurate, because like if there's a difference in latency between experiment and baseline of, I don't know, like 10 milliseconds, that's okay. What we wanted to reduce is like, we don't want a difference of 50 milliseconds, because that will have an impact in CTR.
Okay.
So yeah, but this idea didn't, I'm going to stop sharing. This idea didn't really work. Well, we presented it to the architecture team, and yeah, like there's several problems with this. The main problem is that we can't really get an, like, insert accurately latency in a request. Like that's kind of hard. Initially, we were trying to doing it in a non-blocking way, like using a task.delay. The problem with that is that it's not accurate at all. And
It's not accurate?
like, I mean, we could expect, because, so let's say that you say, okay, let's task.delay 50 milliseconds.
Okay.
The thing is that that's going to to call back, like the task, it will generate a task that it will be ready after 50 milliseconds, but there's no warranty of when that task is going to be executed.
Oh.
So, and what the architecture team, like the ballpark number that they sent was that they couldn't warranty like less than 15 millisecond accuracy, and that was not really good enough.
Okay, so 15 milliseconds, you wouldn't be able to get within 15 milliseconds of the target you were trying to hit.
Yeah, and it could be more or less, like it's not even deterministic, because if it's always 50
Of course it's
milliseconds,
not.
we could just remove it, you know.
Computer is not deterministic at all.
Exactly. So yeah, this idea like was kind of discarded, and the next step was, hey, why is this, any of this job is something that we could parallelize? Okay, let's do it. Let's try it. And this is what we're trying to do now.
Right. Okay, so yeah, that's so this premise that we've had the whole time about like it all has to be single threaded is just like not real, as it turns out. Well, to be fair, in talking with them, they basically were like, okay, you can't just like use all the threads. They were like, you got to limit it to like just a couple. But is that enough to speed it up for the experiment? And then, as we move on, does this get us close enough to test whether it's good? Then we can go back to the drawing board and actually work on the optimizations and yada yada, et cetera, whatever.
It's like, obviously they are not super excited. It's like the the best of the bad ideas, because like this is way better than, like, ideally we would make it fast enough to match the latency of the original algorithm being single threaded, like that's the ideal, but at least we're not injecting latency, so
Right, right. Okay, yeah, that's super interesting. Like, yeah, I am like recounting all of like the last 2 weeks in my head, and I'm like, is there any way we could have saved time? And like in the back of my mind, I'm just like, I really don't think so. Like with everything else that's going on, around the office and whatnot, and everybody's busy, like working around people's schedule to get this kind of like even get these kinds of questions answered has been a little difficult. But more or less, I think like going and showing code and like showing that it works and that sort of a thing makes even a code review where they say the answer is no,
yeah.
like a much easier thing. Because if we had been like, yeah, we'd like to inject latency, and then they were like, okay, give it a shot, and then we walked back to them with like a whole thing, and they told us, yes, we can do this, but then they told us, no, the approach we took is not going to work, like that would have been more frustrating. And if they had told us no up front, we would have been like, I don't believe you.
Yeah.
Because that's kind of what I was like
Plus,
even when they told me that.
Pla- Plus, also, like, it was super interesting work.
Yeah,
Like, getting the math right was super interesting.
yeah,
And also, it was like a couple of days. It was not like huge time. And
right.
we actually proved it that, okay, like it worked. And, like you always learn even out of failed experiments, you always learned. And yeah.
Right. Hey, so we have a question here from someone in chat from World Wake says, "What is latency injection?" Can you just describe that again? They might not have been here when you described it.
Yeah, sure. So, uh, the current baseline, like the current algorithm that selects the jobs that are shown on the ads on Stack Overflow, right now is taking around 15 milliseconds to run. And the new algorithm that we're trying to try out takes around 60 milliseconds. So the idea was that we were trying to inject some latency on the baseline to move it up to 50, 60 milliseconds.
Right. Basically,
So
make the request take longer.
yeah, imagine just like a thread sleep, something like that, where we just waste time doing anything, just delaying the request.
And okay, they replied with, "Why are you trying to do this? Why are you trying to slow down the request?"
Okay, so the reason for this is that there's a measurable impact in CTR, uh, which is the click-through rate in the ads. So people click less. Like we already measured it, and this happens when as latency increases. So if we want to just try, as in an A/B test, the the algorithm itself, the results, we need to like exclude all the external variables, and one of them is latency. Like, let's say that the new algorithm produces more accurate results, and people really like it, but like some of them, I don't know, scroll the page faster, and they don't even see the results or
Or
whatever.
they just see it the ad on the screen for a less amount of time. Like there's whatever
Exactly.
the reality is sort of difficult to quantify, but yeah, it's just one of those things that you have to control for because there is a measurable CTR difference based on latency alone.
So basically, we wanted to see if, like, okay, the results of the algorithm are they better or not? Or not? If they are better, okay, then we can invest time to make it faster and optimize it, like, as much as we can.
Right. Let's go ahead and take a look real fast at I need to go like this and say new incognito window. So on my website, I blogged about some of the lead up to this that we've done recently, and you can get there by going to cultureofdevelopment.com and then just go to blog. And there's the last two blog posts on here are about the work that we did leading up to the stuff that we're talking about now. The stuff that we're talking about now is stuff that we literally were working on this morning and pretty much all this week. But some of the quick wins, we started off in the first episode with a really naive implementation showing the code of almost exactly what we had, and it took about 320 milliseconds. This blog post right here is about some basically just understanding a little bit about what's going on under the hood with just this code right here. And by the end of this blog post, making a few changes, we're able to increase the speed of this code by about 63% without modifying the approach to this at all. And you can read through it. We talk about the Lambda function tax, which is a fun topic that even came up today in our code review. There's also arrays of classes versus arrays of structs and how that reduces an additional lookup when you're trying to reference different data. And the code for that change is literally like change the word class to struct, and all of a sudden we saw a 30% improvement. It was just ridiculous. And then also shrinking the representation, so changing the structure of the actual class that we're using. Let me make this bigger so people can actually read it here. And then also the last one was this one is a bit of a hack, but something that comes up and highlights one of the things that really helped us get a lot further later on, which is basically making it easy to like hide the latency of accessing the nodes in these decision trees. And yeah, the code that we get at the end, this is literally the code. You can find it in the repo, which is linked down here at the bottom. You can run the same test that I was running as we went through here. And that's it. So yeah, take a minute, visit this when you have a chance to get a little bit of background with what we're talking about. And you can read the first one as well. And you can follow along with the code that's in the repo that's listed there, or you can follow along with the code that is in the Culture Development /fast repo. But anyway, Juan, let's go ahead and get back to what we're talking about. I want to change topics for just a moment, and I apologize for not doing this like first, but I kind of want to learn more about you, man. Like we've only had the chance to meet one time in person. God, where were we? In Charlotte, I think.
Yeah, in the company meetup.
Right. And just never really got the chance to talk to you. So I guess I'm just curious about you a little bit. Like, what did you do before Stack?
Okay, before Stack, I worked for 8 years on an US-based online marketing company. I also worked from Uruguay. Um, in that company, like it was completely different size. It was very small. I was kind of like the first first developer in that company, and then another friend joined. He's also working in Stack Overflow, and it was fun. It was fun. It was fun to be in the early days of a company, because like you need to get things done. Like it doesn't matter, and what it's more fun is being 8 years later when you need to pay all the tech debt that you introduced at the early days to get things out of the door. So that's fun. That's fun. But yeah, like the company like specialized in selling leads of insurance, like health insurance, auto, and I don't know, life insurance. And we had some sites that capture the leads, and then we had some background processing to determine like this person is more like do some matching with the companies and send them the leads. And also we had a call center which was created in-house, like from scratch using Twilio and .NET, which was super interesting. Yeah.
That's cool. So you worked there for 8 years.
Yeah.
Wow. Like what? I mean, if it was that small of a company, you had to be one of the first employees.
Sorry?
You had to be one of the first employees?
Yeah, I was like, the three partners. And yeah, I was the first employee there.
That's cool. Okay, this is going to be a hard question, I know, because like this stuff happened a long time ago. But what was like the hardest lesson you had to learn while you were there?
Well, maybe that it was also my early years in my developer career. And I guess that sometimes you need to make things that are not pretty to get them out of the door. That was one of the hardest lessons, because like I was like trying, like in the early days after college, and I was like, okay, let's make things clear and like maintainable and whatever. And it was really a struggle with myself to make things like I don't know, like as not as I wanted. And yeah, like thinking, okay, I'm going to fix that later. And also like using all the different hats. Like we didn't have DBA, we didn't have infrastructure people, we didn't have anything. It was like, hey, okay, this is your server, and okay, like manage it, install everything, maintain it, code, like be a wildcard. Do whatever it needs to make it running. But like I think those type of positions are where you learn the most, because like you're always getting out of your comfort zone. You're not like, you need to do what needs to be done. And
usually very quickly.
Yeah.
That's cool, man. So you mentioned that you went to college. Where did you go to college?
To Universidad de la República. It's Uruguay's public university.
Okay.
It has a good computer science program, and I did my bachelor's. Education is a bit different here in college education, at least in Uruguay. Like a bachelor's degree, it's like a 5-6 years program, and it's kind of very generic. And so you have like 4 years where you have generic classes, and then you have like some courses where you select from and you make some kind of specialization.
Okay.
I think that in the US it's like 4 years, right? Like a bachelor's degree
Yeah,
or
so
something.
in the US you have what they call like core classes where it's like everybody has to take those. It doesn't matter what your degree is in.
Okay.
For a 4 year college. For a 2 year college, it might be a little bit different. But this is things like you have to take English language, you have to take a foreign language, you have to take a class on literature, a class on like history of the world and stuff like that, and then just this and that sort of to have like a broad base. There's like at least in my program there was a couple of philosophy classes you had to take, a sociology class, those sorts of things, and then after that you move into your specialization, or really sort of alongside it. You'll take like the entry level classes, like Java 101, your first year, right?
Okay. Yeah.
And then like as you move deeper and deeper into it, by your last semester, you're basically only taking classes in your specialization.
Okay, I see.
And yeah, it's about 4 years, but you go, I don't know like how many classes y'all take like in your whole thing. For mine it was 120 hours of credit. Some of the classes were 3 hours of credit, some of the classes were 4 hours of credit if they included a lab. So like a physics class would be a 4 hour credit because you'd be in the classroom for 3 hours and then you had to go to the lab for an hour each week.
Okay. Yeah, and you're right. I think that the credit we needed 450 credits to get the degree,
Okay.
and each credit was equivalent of like 1 hour weekly work
Yeah, that's
for a whole semester. So like, yeah.
okay. Yeah, that's effectively what it was like, but I guess ours is around 360, so I guess y'all take more classes.
Okay.
Maybe.
Yeah, yeah, maybe.
Okay.
I don't know.
Um,
Like here, for example, here in Uruguay, it's like not very likely for people to get a master's degree.
okay.
And I know that in the US, it's like for like quite common, right?
I don't
Or
know the answer to that.
no?
I think
Okay.
it's like more common now, certainly, than when I was in school. Like I just got a master's degree and I've been in the industry for what, 12 years between the end of my bachelor's and like I guess I was in the industry for 9 years prior to starting my master's. But yeah, I don't know. I'll be honest with you, I don't know that many people with masters, to be honest.
Okay.
Yeah.
Yeah.
So I don't know. I think that's something we could look up in statistics, but I don't
That's
know off the
interesting.
top of my
Yeah.
head. I do know that the master's programs, at least the one that I took, was like a level above the level of difficulty, like certainly a separate level of difficulty than any of the undergrad classes that I took. In terms of the amount of work, the expectation, the quality of the work, the grade requirements, like everything was accelerated.
Yeah.
So, all right. So, how did you get into computer science? And so, if you went to school for it, did you know about it before you went to school, or did you decide to start when you went to school?
Yeah, I guess I always liked. I mean, I was always into computers. I was not one of those kids that had like their Commodore 64 or something like no. I got my first computer when I was like 15 years old.
Okay.
It was like I got Pentium 3, so it was like quite an advanced computer for early days. Uh, but yeah, I got. I'm not sure how I got it, but I got like a Visual Basic book,
Okay.
and I started just doing some small things here and there, and I was like, oh, so I can basically create things without needing anything but some time in my computer. This is really cool, and it grew from there.
That's
Yeah.
cool, man. All right. Okay. Well, so for the rest of the time that we have, which is basically as long as you want to hang out for, I'm curious. Is there anything that you're interested in learning? Right? You got any projects you want to work on?
Well, today you mentioned in the context of this optimization problem, you mentioned something about vectorization, and I'm not familiar at all with it. So it would be interesting to see how to do that in C Sharp.
Okay. Let's take a look at it. I guess. Let me set up a VS Code visual share here,
Okay.
and then we'll get started and see what we can get through in the amount of time that we have. File, close folder. I don't see close folder. Oh, there it is. All right, here we go. I'm going to create a new workspace, and I'm going to get a repo so that I'm not entirely sure if I have to do that. Let's just open a workspace. File. Workspace. I don't want to open a workspace. I want to open a folder. Okay, we're in culture of development. Let's call this vectorization. There we go. Select folder. Okay, now let's go to my extensions. Oh, where is live share? It is installed. Enable. There we go. Downloading dependencies. Guess I could have had this set up before we got started, but it is what it is.
Yeah. Oh, I have it. Okay.
All right, live share. Let's start a session. Sign in with GitHub. Ready to collaborate. Live share is currently in the auto connection mode that improves performance for collaborators on the same network by accepting incoming. Well, we're not on the same network, so that's not super useful. Invitation link copied to the clipboard. Okay, let me figure out how to send that to you. Pull this over here. Just a second. There you go. See if that does anything for you. I don't know how you... There's like a live share thing over here on the side. I think you can join from over here somehow. Honestly, I've never joined somebody else's session. Everybody figures out how to join mine, so I don't know the answer.
Yeah, don't worry. Okay, I joined.
Okay, so we're in here. So let's go ahead and create a file then. I guess we'll do...
Oh, I need to... In order to join a collaboration session, I need to sign in. Okay. No, I don't want to.
Okay, let's use .NET for this. .NET new console. And we're going to call this vectorization. Oh, I have to do .name. All right, I'm pretty sure... Oh, there you go. You have joined the collaboration session.
Yep. Okay.
Oh, give me just 1 second. I'll be right back. I have to pause this for just a moment. I left my dogs out, and my babysitter just got back, and she's afraid of dogs. I'll be right back. Okay, sorry for that. I heard my babysitter come in, and all of a sudden the dog started going completely bananas, and I was like, so I had to run upstairs and like stop him because she's like not, she's nice and short, and my dog is kind of big. I got a nice big lab, and he likes to jump up on her. Yeah. Okay. All right. So can you open the file? Can you open? Yeah, there you
Yep.
are. Look at that. That's awesome. All right. You're gonna drive, since you're the one doing this, and I'm gonna watch. Basically, sound good?
Okay, sure.
Okay.
S-
So for
Yeah.
this, let's do something pretty typical of like a lot of models, right? So in linear regression, logistic regression, what we end up with is basically a dot product of two vectors. Like
Okay.
let's go ahead and start with that, and then we'll move on to some more interesting things. But you'll find out that yeah, just implementing that will save you an incredible amount of time.
Okay.
Okay.
Um, should we uh should we add any packages? Or
Probably
I think it's in,
system.numerics, I think.
yeah, let's see if we have already that or if, yeah, we have it. Okay. Whoa.
Actually, we
Okay.
don't have it. What we have is the system.numerics that includes big integer, but you still have to go and get system.numerics.vector
Dot
from,
net.
yeah.
Okay.
Are you familiar with how to do that using the .NET SDK?
.NET add package.
Yeah,
Yeah. Let me see. I'm not being able to. Oh, I need to request for permission
there you
to.
go.
Okay. Uh, sounds like. Oh, we're not here.
I think you have to.
So,
Oh, yeah, yeah. That's silly.
CD vectorization. Okay. Let's try it out now.
Perfect.
No vector, no vectors, maybe?
I think you.
Yeah.
Yeah, okay.
Okay. So let's say that an array of two arrays of floats, maybe.
Okay,
We're going to receive that.
sure.
Okay. So let's say that float,
So a dot product just returns a single float.
a single float. Okay. Oh, so we are going to multiply like both arrays
And then
and
sum them all together.
sum them all. Okay,
Yeah, yeah.
got it. So float. And let's see how this works. So I guess it sounds like
Why don't we start by just making a typical version of it so that we have something to compare the value to?
great. So let's define an accumulator. Uh,
Yeah, that looks good. Now let's make something where we can get the value. Let's do a quick little test.
or we can get the value. Okay.
Yeah.
So let's get up new. How many values do you want?
I don't know. Let's do kind of a lot. Let's do 1,000. Yeah.
Okay.
I think the idea of doing 1,000 is sort of like it's enough that we ought to be able to measure any speed up.
Okay. Well, actually, here I could do like, do we need floats or can we do it? Because I could do something like, or do we want some random numbers?
Well, probably random numbers, but
Okay.
seed them so that you can regenerate the same thing.
Uh, let's do 4 here. Oops. Maybe doubles? Use doubles?
Sure, just be sure to convert it to a float, I guess.
Yeah.
So next double returns a value between 0 and 1, right?
Yeah.
Okay, so that's good. So you gotta keep in mind that as you're adding these things together, the value can get quite large when you're multiplying and then adding together.
Yeah.
So keeping the numbers kind of small will keep us from overflowing.
Well, but if we are going to multiply, so we're going to multiply two numbers less than 1, there will be like even less than their each of them, right?
Right.
So and each of them is going to be less than 1. So we're looking at a total sum of less than 1,000,
Yeah, which is great
right?
because like as you get above,
Yep.
a
Yep.
few thousand, or I don't know. Actually, that's a good point. I don't know how high you can get before you start really losing precision on a float, but I would imagine it's not too much past 1,000.
Okay.
I kind of want to know that now.
Should I just, would this just work? I have no idea. Like,
Right. So World
I
Wake.
ha-
So we have a comment from World Wake, something like 7 decimals. Yes. So you can lose precision on the low end, but you can also lose precision on the high end, right? When you're adding together a ton of numbers into a float cannot like accurately represent numbers that are like in the millions.
why don't we do, in that case, like, we are getting doubles, so we can, right? And we avoid the,
Normalize everything to begin with. That's not a bad
yeah,
idea, yeah.
float, okay. So, and what is here? Can it implicitly, 0D. Okay, so now we can call like console.writeLine, multiply, okay. Oh,
I think you want to seed that random so we get the same value each time.
okay. Uh,
You just pass it in, I think,
yeah,
yeah. Looks good to me.
yeah. Okay. Should we? I'm not sure if can I run from my side.
Mm-hmm.
So should I .NET build? Will that
Yeah,
work?
.NET build or just .NET run.
Okay. Oh, the lag in the console is real. Okay.
Okay, there we go. 252. Okay, great. Let's run it again. Make sure we get the same value. Okay, perfect. Okay, now let's do the vectorization.
Okay. So static double multiply vector multiply v, and well, yeah, let's just copy this, and let's see. So we need to define two vectors, I guess. Equals mu. From what I saw, I think, can I? Yeah. But I have to be honest, I checked a bit this out before the stream. And what I saw was that we actually need to take into account this value, vector double dot count. Because I tried to do like, well, maybe not. Let's just try it.
Sure.
v2 equals 4. I'm not. Whoa, I lost my mouse. Okay. Yeah. Let's just okay. And is there a method for this like dot?
Yep.
Yeah. Okay. Nice. v1, v2. So double. Why are you complaining, my friend? Let's just read out. Oh, let me.
All right. From now on, before we run these, I want you to tell me what your expectation is.
Well, my expectation is not to have a difference of 251. Okay, so my theory here, I'm not sure if it's true, but is that so we're trying to do some certain of operation in parallel, right?
Mm-hmm.
But we're just getting the amount of whatever amount of data registries the CPU may have in parallel, right? So should we account for that? Like,
So, sort of. Real fast, there's a comment in here says,
yeah.
World Wake, what's the difference? The picture is on top. I'm not entirely sure I understand what that means. Oh, the picture. Your picture. I'm going to move
Oh
you
yeah.
up here. There we go. Now you're out
Just
of the
remove.
way. Okay, now the difference is 252 versus 1. So it's quite intense here.
Yeah.
Okay, so there is there is a maximum length to a vector because a vector here is sort of like a C-sharp construct. Okay, this is not like a class or a struct in the typical sense. This is more like a compiler directive, right? And this compiler directive says, when I see this thing, I want to basically shove all of this stuff into a register that lives on the hardware itself. Okay?
Okay.
That register has a set size, which you can access by vector.count. Or, well, vector
Okay.
double.count. And so what we need to do is we need to look at that size and we need to repeat this as many times as possible until we have gone over the entire array. So there is an overload to new vector double that takes in an array plus an offset.
Oh, okay.
All right, so what we want to do is for, like a for
Let's.
each over the size of the arrays.
So it's I r1 dot length, but we should kind of divide it by that count,
No,
right?
no, not divide. We should add the number of values we're going to be doing at the same time.
Okay.
Nope, not here. When we
Yeah.
increment.
Oh, okay. I see. I
Yeah,
see. I
yeah,
see. I
yeah.
see. Okay. Yeah. It's yeah. Uh, equals plus. Well, and now it's vector double dot count.
Right.
Okay, and now I can do, so I'll define an accumulator here. And I can do vector dot, so sum plus equals, and new vector.
You already have it right down here.
Yeah. Yeah, let's just do this. And And here, oh, the starting index. So let's pass by.
All right, that should be better, but I'm not 100% sure if it's correct.
Yeah, let's try it and see.
Hey, look at that. All right, you will notice that there is a little bit of difference.
Yeah,
So that happens because of rounding error. Are you familiar with that concept?
more or less. But yeah, if you can explain a bit in depth.
Yeah, sure. So the way that rounding error works is when you have two numbers in a computer, there is a set number of bits that represent those numbers, right? Which means we can only represent certain values. We can't represent all values between
Yeah.
0 and 1. Like there is a finite number of values that we can represent. When you multiply two numbers together, you're throwing away some information, right? Because you've multiplied these two things, and if they fall in between one of these two things, it's effectively random which one you get, right? Whether it's the high end or the low end. And
Okay.
so when we do this over and over and over and over again, we're throwing away a little bit of information, 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 right? When we were doing them in order, we always get the same values because we're doing them in the same order. In this case, we're not doing them in the same order. So you get a little bit of different values because you're throwing away a little bit of different information.
Okay, I get it.
Okay. So it's okay that the values aren't the same. They should be fairly consistent across runs, but it's not a guarantee.
Okay.
All right, so if you were to run this like three times, you might get three different answers for the second one, but because the difference is so little in
Yep.
this case,
There you go. Oh no. Yep.
they
No.
look the same
Same.
this time.
Yeah.
Okay, but we'll notice here that the difference is like, what is that, 10 or 11 decimal places, so we're getting really good accuracy here. As you
Yeah.
increase the size of these arrays, you're going to find out that that's not true. All right, so now I want you to do something. I want you to rewrite the code up here at the top in the main function so that instead of
Yeah.
doing 1,000 length, let's do a 999 length.
900? Like 900? Sorry.
That's
How much?
9,000. Yeah, do 999.
Oh, one less. Okay. Yeah.
Yep.
Let's. I mean. Okay.
All right, let's try it again. Oops.
Uh. Okay.
The
You
dot
tricked me.
product is linear, so we can do it piecewise also. The dot product is linear, so we can do it piecewise also.
Is there an overload? No.
Describe to me a little bit more about what you mean by doing it piecewise in terms of the order of the operations, please.
Sorry,
This,
a piecewise?
sorry, I'm talking to someone in the chat.
Oh.
Okay, so you have a problem. Why don't you go ahead and debug that? You're calculating the dot product of two vectors which are in 1,000 dimensional space. Okay? You have any idea what the problem is?
um. I I guess it's like the vector here. It's trying to just do like I plus, like getting like I plus vector count. So it's getting out of the array effectively, like the
Right.
internal representation. So I guess we I guess we could fix this to always have a multiple of and like a multiple of vector count here and add zeros to the part that we don't want. So let's say that we effectively have 999 numbers.
Mm-hmm.
So we could like turn it into 1,000 and put just zeros on, like trailing zeros.
So that is one way that you can do it, but how are you going to achieve that?
Oh, yeah, I can create a new array, which would be expensive.
Yeah.
Uh,
Let me read these comments real fast. The dot product is linear, so we can do it piecewise also. You're calculating the dot product of two vectors, which are in a 1,000-dimensional space, but you're splitting the dot product into a sum of dot products, and it works because it's linear. That's right. Yeah, it's just the order in which the operations, the floating point operations happen affect the the uh, the precision, I suppose. Like you get a little bit of rounding error. If you do all of the operations in exactly the same order, you would expect that rounding error to be consistent. However, since we're doing them in a separate order, there is going to be a little bit of difference. But it's super, super, super small. But yeah, everything you're saying is correct and makes total sense. Okay, so let's think of ways to solve this.
okay. So, so here, I'm just thinking that here we could go until, like, I'm going to do an integer division to vector double dot count times vector double count. This is not great, but
All right, so taking advantage of
integer
integer.
division to get like so this way, if we have, I don't know, like, it would go. I mean, let's say that count is 5. We're going to go until 995, and then we just, I mean, we could do it without vector, like for like I equals whatever, and like complete the other part without vectorization.
Okay.
I'm not sure how big count is, because if it's 5, that's okay. Like if it's not, I don't know, like a big number, which I don't think the CPU will have that.
Depending on
Yeah,
depending on what data type you use, count can get quite large.
because if it's large enough, like it might make sense to here create an array for count length, and do the thing what I mentioned about like adding trailing zeros.
Okay, so let's just get to a working solution, and
Yeah.
then we'll talk about how to clean up
Okay.
the
Okay.
details.
Equals so yep. I minus or one dot length. I can just do here. Well, I think this might. I think this might do the trick.
Okay.
Should we try it out? Let's see. Nope. Whoa.
Well, there's a good
Oh
thing.
no! This is. I forgot this. I forgot this part.
Hey, all right, there we
There you
go.
go. Okay.
Okay, perfect. Interestingly,
Yep.
the sum of the first one changed kind of dramatically. Why on earth did that happen? Look at the output here from the previous runs to the current run.
Oh yeah.
How did it change that much?
May, Maybe random is not just about the seed. It's the seed plus something. I don't know.
I feel like it ought to be consistent. That is really weird. That is really weird. I don't know the answer. Oh no, we changed the size. That's what it is. We
Oh,
changed the
yeah.
size.
Okay.
Okay,
Yeah.
all is well. Okay, so this let's go ahead and let's get some timings, man.
Sure. Okay. So we could do something like stopwatch. Well, I mean, we could introduce like benchmark.net, right? But
We
yeah,
could.
let's yeah,
I think a stopwatch will probably get us close enough, but
yeah.
we'll just have to run it like 100 times or something.
Yep. Um. So sorry, this is not the way to start new stopwatch. For stopwatch dot start new, I think it is start new, something like this.
Okay.
Did this work?
You just need
Okay.
a using system.diagnostics.
Yeah, but I mean, I'm not super familiar with VS Code. Like in Visual Studio, I just do control point and it just, yeah.
Oh, I think
Uh,
it's just a different thing. Like if you hover over it, it'll pop up with like a little thing for quick fixes. Oh, it doesn't think there's a quick fix. Well, it seems to have
yeah.
worked.
Let's see. So, do you want to do like how many iterations?
I don't know, you decide. It doesn't really matter to me.
Okay,
I would not do so many that it takes a long time. Let's just take a look at what the timing is.
yeah, let's do something like this. And like, we don't really care about the number, the result.
Well, we do, because we're gonna make changes. I would say
We're going,
just record the result in something. You don't have to write it out inside here. Just record.
okay,
Yeah.
equals 0. What we're doing, doubles. Let's sum everything here. And let's do the same thing here and like, sorry. Okay. Result one.
Just set it equal to it. Let's not add it.
Okay. Okay, and now we can do here like console dot writeLine SW elapsed milliseconds, I guess. We don't really need to do it, but yeah.
Okay, so I'm gonna suggest a couple of changes. First, this
Yeah.
result 2, and then we also need to do int I for each of these.
Oh, yeah. Whoa. Bar. Okay.
This,
And what's the problem with? Oh, result 2. Okay, yep.
yeah. Okay, and then I also want you to throw a stop in here before you write to the console. It's quite expensive to write to the console, and we
Okay.
don't want to count that time. Same down here.
Yep.
All right, let's see. Let's make sure we print out the results 1 and 2 at the very end, just to make sure that we're still seeing those.
Uh, okay. No, this didn't build. Oh, sorry.
.NET Run will build.
Yeah, but as I thought that it would like it failed or something. Like
It's
why it's
definitely
not
not writing out what we expect it to.
exactly? I thought that, yeah, it was running the a previous version that didn't compile for some reason.
uh, Let me close this and reopen it. I have made
Uh,
changes. Do I want to
oh,
save?
file to save is newer. Please compare your version. I'm having a problem here with live share.
Here, let's try that.
Try saving. Okay.
Okay, there we go. All right, so clearly we need to up this from
Yes,
100
here.
runs. I also want you to
That's so
change the
crazy.
way that you print out. Instead of doing elapsed milliseconds, which is a long, which you only get integer values of, do .elapsed.total milliseconds.
Elapsed dot total milliseconds. Okay.
And that will give us a float value, which will give us partial milliseconds.
Okay. Oh, I can save. You need to save it.
Oh, man, that is weird. I'm not gonna lie, that's weird. It's I don't I don't understand that either because you were doing it just fine earlier.
Yeah.
Oh, our values are different. Oh no, our values are the
No,
same.
no.
Our runtime is different.
Yeah.
Okay. Let's see. Let's go ahead. I'm gonna do one more thing up here, which is uh, int iters equals 10, like that. And then we're gonna change this to iters so that we can change it easily in one place. Okay. Now let's run this one more time.
Yep.
Okay. All right, what we notice here is that it's about 280 to about 240, right? That
Yeah.
clearly is not half the time. First off, let's figure out what sort of speed increase we expected, and then let's see if we can get closer to that.
Okay. Why don't we print like vector count to see what, like at least what, how much are we are parallelizing?
Yes, that's a great idea.
Okay. Let me just. I'm going to print it here. Please save for me.
It won't let you save?
Now I have something here that says compare, but
Try
apparently
try closing it and reopening it. I'm going to let you open it first.
okay. Let me try to. Okay, I'm going to try to make a change
Hey, all right.
and
See, it popped up on mine.
yeah, okay, nice. Let's run it now. Okay, 4.
Okay, so we expect a 4 times speed up,
Yeah.
right? But we're not seeing that. So let's think about why we're not seeing that and how we can possibly improve that.
Well, I see two things here. Like I think that we are like wasting, not wasting, but investing a lot of time moving the data from the array to the vector. Like I'm not sure how this is implemented, but like maybe some data is being copied some from the array to the vector.
Okay. So I think it's going to actually turn out to have a little bit to do with these vectors dot counts. I don't believe are constants, and they're making actual calls to the hardware. I think the hardware might do it one time, but this is a
Yeah.
lot of math to be doing on every iteration.
Yeah. So and I just got it and let's do like this, like parallel vector v
You got to be very clear
and
here. This is not
index.
parallel.
Sorry.
So this is not parallel. Like we're
Yeah,
not using multiple
yeah, yeah.
threads here. Yeah. Okay. All right, and then as crazy as it sounds, this one right here, I think I would also swap out.
Okay.
But we can check that by running it twice.
Oh, I can't. Again, I can't save. Please save.
It must have a bug. Okay, I've saved.
Okay.
Oh, that's much better.
There we go. Yeah.
Okay, we're still not at a factor of 4. So let's keep thinking about what's going on, why we might not be at a factor of 4.
Let me just. Okay.
Tell me what's going
I
through your head.
I know. I'm just. I don't know, but I'm just trying to understand like how this vector works like just like some sort of span, or is it actually like copying four items into the vector, like it's creating like a new structure or something where it's going and it's creating? Because if that's the case, we are like copying two very big arrays.
Right. So this is not a like in-memory structure. This is a register on the processor. Right?
Okay.
But we are copying the memory from the locations that the data is in to this register. Okay?
Okay.
So there is some amount of pain in doing that. However, you should still be able to improve this a little bit. Another thing, is this running on your machine or is this running on my machine? Because we might have different AVX installed.
On your machine.
Okay, this is running on my machine. Okay, then 4 makes sense. Okay, so as we're going through here, yes, there is a cost for actually copying this. You are not going to get away from the cost of copying the array values into this register.
Question.
Okay.
Why don't we measure? How bad is that? Like, let's remove dot and let's see what's the cost of just creating this.
Okay.
I mean, I'm not sure if moving the data to the register happens on the new or if it happens on the first usage, but we can try it.
Okay.
Okay, so out of 176 milliseconds, the actual vector dot, it's only 46, right?
Sort of, yeah.
Kind of, yeah.
Yeah.
So the rest.
You're not doing an accurate test.
Okay.
You're still doing this work.
Yeah.
This is serial, right?
Let's just. Why don't we comment everything? Is that correct?
It's more correct, yes.
Okay.
Okay, so we're still getting closer. So we saw that just getting rid of this last one chops out about 21 milliseconds, and we ought to get pretty close to that.
Oh, but we're not doing vector dots, right? Like, what I was trying, like these 109 milliseconds don't seem to be related to, like, they are just overhead of everything else, right?
I mean, sort of. What's the right way to say this? Okay, there is some amount of baseline here, right? Like,
Yeah.
the way that we're calling this is we are also including all of this time up here.
Yeah.
for looping over all of this. So like it would be insane, but to call this, 100 times in a row or 1,000 times in a row without doing this loop, even that wouldn't be good because you'd be increasing the size. How are we going to measure this more accurately? Let's unroll this a little bit, okay? What I want you to do is I want you to do this, say, 10 times in here, like
Okay.
this. 2, 3, 4, 5, 6, 7, 8, 9, 10. And the same thing up here. And then we'll divide this by 10 up here. All right, and let's try that. So we're going to do the same number of iterations, which is 100,000. Only this time we're going to get rid of 10% of the cost of this. No, 90% of the cost of this.
Should I go back to the full thing?
Should you go back to the full thing?
Yeah.
I'm confused.
Like what I did was just to get the vector dot to execute. Below?
Oh,
Below?
yeah. Go back to the full.
Yeah.
Yes,
Okay.
go back to the full
Yeah.
thing. Okay. So 176. Now let's think about. Oh.
Don't worry
We're
about
doing
this.
one more thing that we shouldn't be doing, which is we should be doing this in release mode. Okay, that's a much more accurate time of what would be like a production thing. All right, so we're at like a 50. I guess it doesn't really matter. It's a little bit off. Right, this is a 50% reduction. This is not a 50% reduction, so I think we'll stick with doing release mode here.
Yeah.
Okay. So overall, this is not bad. We can increase this by a factor of 10 and still get it done in less than a second. So I'm going to go ahead and do that just so we can get even more. Okay, there we go. All right. And let's make this a const so that we're not paying the price. Result 1, result 2, both the same value. Okay, great. Okay. So I want you to think about this for a moment. And right now what we're doing is as many as 4 additional summations and multiplications here.
Yeah.
Let's make this one use something a whole lot like this.
Okay. I'm thinking how to achieve it without.
So the way to, yeah, the way
Oh,
to, go ahead.
okay. I mean, there is. Oh no, sorry. Go ahead.
No, you go ahead.
Like, is there a way to add, like, vectors are immutable, I assume, right? Like, you can't just go in a for and no. So we need. Okay, so I'm thinking. No, I don't have great ideas for this actually. I mean, without making an array copy, which I don't know, it seems like more expensive because I mean, it's a for loop anyway, so.
Right. So it turns out that these vectors, you can take like v1 right here, and you can just, I'm not getting any IntelliSense here at all. You know, 0 equals...
Oh, can you do that?
There's a way to do something very similar to this. I just have to look up the documentation for it. C# vector class vector struct. Vector t? Where's vector t? Okay, properties. Oh, it's only a getter.
Yeah, I think it's immutable.
Creates a vector starting from a specified index. Okay. Well,
I mean,
I suppose then that is not going to be as easy as I thought it was going to be.
first, why don't we measure like if this is actually having an impact by putting this like
Just eliminating it?
yeah, eliminating it and using 1,000 here in the 1,000 length arrays to see like if the difference is between baseline and between multiply and multiply v,
Okay,
like
that's a good idea.
it's different. So, whoa. Okay, so, oh, I can save. Let's save.
Oh, there we go.
I mean, the
Let's
multiply v, it's basically the same, right?
let's try that one more time. My initial answer is yes. Okay, yeah, then my initial answer is yes. That one doesn't actually matter. So then the only other issue is trying to speed this up. I'm not entirely sure that we're gonna be able to speed this up too much, since we can't set individual values. But one thing that we can do is, how are we going to speed this up? So this sum right here is happening 1/4 of the times, and we ought to be able to vectorize this sum if we take the results of these and stick them into a buffer, and then create the vector out of that buffer, and then sum up the values here. We can basically take this and reduce this number of sums by an additional 4.
I see what you're saying. Yeah.
I'm not 100% sure that this is actually going to be an improvement, but it's worth a shot.
Yeah, let's do it.
And I would probably make this a static, so that we're not allocating each time we come in here.
Whoa, what did I do there? Whoa, double, and we're going to use here vector vcount, and here we're going to put vector dot sorry, we're going to do sum of I module vcount equals, and now if this if is going to kill us.
You have sum in here twice. We're going to have to change one of these.
Sorry, which ones? Oh yeah, okay, I'm going to yeah. Let's just do that for a moment. So sum, and if I equal and I'm going to do vcount minus 1. That's going to be, so it's, if it's 0, it's going to be 0. Yeah.
So before we get too far into this, there was a suggestion in chat from WorldWake
Yeah.
to put these new vectors directly into this dot instead of going through here, instead of assigning them to variables and seeing if that
Okay.
fixes it. Like intuitively, I would say no, it's not going to. Certainly worth a shot.
It was a shot. Yeah. It's like a quick update. Okay. So Victor.
Let's put
And some. Oh yeah, new vector. Is that it?
sum plus equals.
So oh yeah.
Okay, let's try that. Not faster. Let's run it one more time. You're paying the JIT cost on that first one. Wow. Ouch.
It's weird that it's actually increasing, right?
I mean, it's got to do with my computer also, right? Like
Yeah.
I'm streaming, I'm on a Hangout at the same time.
Yeah.
Whichever processor it ends up on, like it's gonna pay a penalty.
I mean, it makes sense. We can just keep it there.
Okay.
And here we can do something like sum total. And here we should do like a new vector,
Yeah.
right? Like new vector double and pass sum.
And that should be it.
And is there here like a sum or something?
No, it's the
Because
same thing, vector, and then you gotta call something. And this one, it turns out that although there is an instruction available, it's not exposed in the version of .NET that I have installed. In .NET 3, in .NET Core 3, all of the instructions are exposed. But on ours, we have to hack it, and we have to do a dot with a vector of all ones. So,
oh, okay.
okay.
So I can just create a
No,
var
there's a constant for it. Vector
here.
double
Yes, sir.
dot ones.
Oh, nice.
Yeah.
Vector double dot one. Nice. Okay. Uh, plus equals.
Right?
Yeah,
Uh,
right.
I equals v count minus 1, then we want to do this. So it's really if
Oh no, sorry. It's vcount. There we
equals
go.
equals what?
If it's like so, if it's we have four, right? So we're
Mhm.
going to do this in 0, 1, 2, 3.
Yeah.
So 3, we're completing it. In 4, we start again.
Okay.
5, 6, 7. In 7, we do it. Okay.
Okay. This sum down here needs to be cleaned up.
Oh yeah, sum total. Please save.
One more.
Oh, sum total. Yep.
There we go. All right, let's try that. Ooh, not better. Also, the results came out as 0, which is not good.
Sum total. Yeah. That's weird.
Let's see if we can debug what's going on here. It seems like it is never hitting this.
Yeah, because we are in 1000, so this is never running. It's
Checking out for the day. See you around. Was fun.
Look
Yeah,
at
thanks
this.
a lot for joining, man.
Bye bye. Hey, look at this. The problem is that we are actually going in steps of V count, so it's never going to be V count minus 1.
Ah, right. Okay, so instead, what do we need to do?
So we're going in steps of V count, and we are going to, so this sum would be in 4 plus 4 times V count, right? Oh, this, let me see. It's not something like this. Because if I is being multiples of V count,
This is going to be true for about 3 in a row. 4 in a row.
so let's see. The I would be, we'll start with 0, then it would be 4, 8, 12, 16, whatever.
Okay.
So
Which ones do we want to trigger on?
E every 4,
Okay, so
right? So it would be like this.
so we want to trigger on 15, and we want to trigger on 20.
No, but I it's taking these values, like we can't really trigger, right?
Right. Yeah, you're right. You're right. So we want to trigger on 12. We want to trigger
Yeah.
on
On 28.
28.
So here, like it's 0, 4, and whatever, and in 12, it's 12 over 4. It's going to be 4.
12.
If it's going to be 3, sorry, it's going to be 3.
Yes.
So 3, 4 minus, so it's 3. This is true.
Okay.
Like 28 over, this is going to be 7. 7 modulo 4, it's going to be 3, which is okay.
Okay.
Let's see what this does. Oh, I didn't save.
Oops.
Can you save?
Okay. That is the weirdest thing.
Yeah.
Oh. So it
Okay.
did some of the work.
It did some of the work.
But regardless.
And we're very slow.
It is what it is. It happens. Okay. So I think first off, this might be kind of the problem, part of the problem, right? We're doing a lot of math over and over and over again here that doesn't really need to be done.
Yeah.
But this can be, yeah, this can be set to a constant. This can be a buffer that lives outside of here as long as we don't call it multi-threaded.
Okay, yeah.
But still, we're having issues where this if statement is causing problems. Now, we already saw that math has a fairly large impact, so is there a way that we can change this to be more math efficient? Right? Divisions in particular are quite expensive, and modulos are quite expensive as well. Although I don't think we're going to get away from a modulo here.
What if we go in steps of, like, instead of going like this and going, like, we go the other way around. We go by the amount of...
Wait, no. This is the entire problem. You're moduloing V count here, but we're increasing by V count. You're always setting this to 0.
Okay, yeah. So it's the same thing, right? We need to do V count.
Yeah. Let's see if... let me save.
Yeah, let's see if the math is correct, and then we can.
Much closer? My guess is going to be that the last iteration is not happening. No, 1,000 divided by 4 is an even number. No, it's not, right? This divided by
Yeah,
16, and it's not 1,000 divided by 16 is not an even number. So after here, we still have some additional work to do to clear out the rest of the buffer,
yeah.
and then do one more where we do this.
I mean, either way, like if we need to do extra time, extra work, we're going to still add extra time, and we went from half of the original thing, right, to a 50% more. It's like
Yeah, we sure
we're
did. Okay, let's try something else. Let's change this completely. Um,
yeah.
we have seen. Okay, so let's go back to the code that we know
Okay.
works and was the fastest.
So let's remove this, and I think
I would
this
also.
was
Yeah, no, go ahead.
it. Yeah, I think this was it. We can define this as content, and this can, like, we can pass this as an.
Can you think of a way to do this
I don't know.
without doing the division?
Where is this? Without doing the division.
Right. I'm going to hold that this is quite expensive.
Yeah.
I don't think it's like so expensive that it's, forcing it to go from half the time to 4 times. Hey, oh man. I am trying really hard to read your name, but it is coming up as like almost the same color. Oh, there we go. I just highlight it. This is negotiation of negation. Oh, negation of negation. Hey, welcome to the stream. We are working on learning some about implementing vectorized code in C Sharp. And what we're trying to do is get our runtime to be a linear scale speed up, or as close as we can, based on the number of SIMD register, or the size of the SIMD registers available on my machine, which is 4. Right now we're at about 50% speed up. So let's see if we can keep going. Okay, so let's hard code this for a moment because we know the answer, and let's see if it actually makes a difference.
Yeah.
And then after that, if it does, then we'll figure out a way to do it faster. And if it does not, then we're not going to worry about it.
So like right now we don't even need it. That's the beauty, because we're using 1,000, right?
Yeah.
We can just do this.
So what is v index then? Array1.length?
Oh. Yep.
Okay.
That will work. Let's just do, just so that we don't update the code a lot. Please save. Sorry.
Does it tell you every time?
Yeah.
That's
Like
so
a pop-up.
Okay, it doesn't make a difference. That's what I just learned.
Yeah.
Okay, so let's not worry about it then. Let's go ahead and pull that back. I want to do one other thing real fast, which is we don't seem to be speeding this up at all, but let's consider what happens if we change the data type from a double to a float, right? A float is half the number of bits or I guess half the number of bytes as a double.
Okay.
So if we
Let me
do that, it's
just.
going to be kind of a pain.
Double with float. Let's just. Poof. Oh, do you mind saving?
Oh, it's me.
I'll probably need to do some.
This one right here, it doesn't like this.
Yeah.
Whatever.
And this one.
There is no next float. There's just you got to take next double and then convert it to a float.
Yeah, I just did a find and replace double
Yeah.
by float. So next float. Let's see what if. Please save. And you're like my controllers.
Oh wait, what is sum total? Oh yeah, another one here. F.
Oh, okay.
Okay, let's try that. I think it's silly it doesn't just take care of that on its own.
Okay, now it's 8.
Hey, all right.
Yeah.
Okay, so that was not quite a reduction by a speed of 4, but you see we're still making improvements. Like we're doing more operations. So the reason I thought this would actually have half the time of this is because we are not loading data any slower. It's not like a loop that goes over it. The way that
Yeah.
this sort of works under the hood is more like a blit. Are you familiar with that term? It basically
No.
is saying take this much memory from this
And
location
put it.
and shove the whole thing over there, and we haven't changed that at all.
Yeah.
So I sort of expected it to do a little bit better than this, but I guess that's just the way it works. Vector floats array I dot. Interesting. Okay. Well, that's kind of cool. I mean, that's a pretty big speed up for like
Yeah.
not really doing a whole lot. The
Yeah,
code's a
really
little
like
ugly.
it's. Yeah, but I mean, we can make it prettier, but like it's not a lot more code, and it's what, like yeah,
Yeah,
a
and
big
what,
performance improvement.
3.5 times speed up? It's a pretty
Yeah.
big one, yeah. I really do want to make it faster. I think we can. I just can't think of how. I bet you it would be faster if instead of using .NET 2, we were using .NET 3 SDK. I know they put a lot of effort into this and that.
Okay.
Anyway, yeah. Um, that's it for dot. Do you want to do another one or you want to give up on
No,
it?
that's okay.
Okay,
Yeah.
that's cool.
I.
I think so. It's 2 o'clock. It's been about 2 hours on the stream. I think it is about time to go ahead and wrap up. I would really like to thank you for joining me today. Let me make you bigger over here so people can see you.
No problem. It was my pleasure.
Yeah. Thank you. Yeah, thank you so much. I really appreciate it. It was great to learn a little bit more about you. It was great to chat about the stuff that we've been working on for the last 2 weeks. And, now we've got some documentation, some evidence
Yeah.
of the stuff that we did. And also, this project was fun. Like, I learned stuff right here. I really thought we were going to be able to get this sped up a little bit faster. Still kind of interested to understand why it doesn't, but overall, pretty interesting.
Yeah.
All right, man. So that's it. Thank you, everybody who stopped by. I would really like to thank everybody who dropped a line in chat. Lurking is totally cool, too. And I will see you all next week when I intend to get on a much more regular schedule with streaming. These past 2 weeks have just been really kind of eaten up by dealing with this project that we've been working on. And thanks again, everybody. And we'll see you all soon. Have a good one.
Bye.